Hi everyone, welcome to the 7th module of Verilog HDL crash course. In this module, we are going to cover concepts related to behavioral modeling, and we are going to cover the first part of this module, where at the end of this video, you would be able to understand about behavioral modeling and the procedural blocks used for behavioral modeling, and also you would able to understand the two types of delays used in Verilog HDL, which are inter-assignment delay and intra-assignment delay. And at the end of this video, you will be able to understand the concepts of begin and end keyword used in procedural blocks. So now let's get started. So friends, if you are visiting first time to this channel, you can consider subscribing so that you would be able to get more contents on VLSI concepts. So the basics of behavioral modeling I have covered in our module 1, where we discussed about different levels of abstractions in Verilog HDL. So you can also go through that particular module. I will provide the link of that module in the description section of this video so that you will be able to understand the basics of behavioral modeling. So as a reminder, behavioral modeling is nothing but the Verilog HDL coding style when we are only given a behavioral description of a design. So based on the behavioral description of a design, we have to model the Verilog HDL. So that is nothing but behavioral modeling, and there are two important procedural blocks used in behavioral modeling, which are always and initial blocks. So behavioral modeling provides a powerful ways to doing complex design, and behavioral modeling basically make usage of two types of procedural statements, and the procedural statements can only be used within two types of procedures, which are always and initial blocks. So we will also study what is difference between always and initial block, and where is always block is used and where is initial block is used in more details in upcoming modules. So procedural assignments are assignment statements used within Verilog procedures, which are always and initial blocks. And as I covered in our previous module as well, only range type of variables and integers can only be placed at left hand side of the expression. And very important point, the procedural assignments happens by making use of two types of characters, which is equal and less than equal to. With this is basically called a blocking assignment, and this is called a non-blocking assignment. We will cover blocking and non-blocking both type of assignments in next slides. And the right hand side of the assignment in an expression in a procedural block can be any type of the data type, which we discussed in our module 4. Now let's understand first the different types of delays used in Verilog. So basically there are two types of delay assignments used in Verilog, which are called delayed assignment, and this is also called sometimes inter-assignment delay. So don't get confused. Sometimes it can be mentioned as inter-assignment delay, and sometimes it can be mentioned as delayed assignments. And the second type of assignment is intra-assignment delay. So in the delayed assignment or inter-assignment delay, what happens is whatever time is mentioned, the statements gets executed after that much of time. We will see this in more details by making use of an example. And in an intra-assignment delay, what happens is the right hand side expressions gets evaluated immediately, and it gets assigned to the left hand side after the time mentioned in the expression. So the basic difference here between the delayed assignment and the intra-assignment delay is, in a delayed assignment, the right hand side expressions gets evaluated after the time mentioned, and the result of that expressions get assigned to the left hand side variable after that much time. And in intra-assignment delay, the right hand side expressions gets evaluated immediately. So let's see this first, the syntax. And another important point here is the delay assignments are not supported by synthesis tool. So very important point here to note is the delays assignment we can only use for simulation. That means any type of delays are unsynthesizable constraints and they should not be used in the real design. But for simulation purpose, we can make use of them. So the syntax here is, this is a normal expression where we have a left side variable and we have a right side expression. Then in a delayed assignment, what happens is, this is the expression for the delayed assignment where we have to mention the delay unit by making use of a hash character, and the time for which we want to delay the assignment. And in intra-assignment delay, the delay time value is mentioned at the right side of the expression. So let's see one example here. So we have three variables a, b and c, and our sum is b XOR c. So there are no delay mentioned in this expression. So these expressions will get executed without any kind of delay. But in our next statement, what is mentioned is sum equal to #15 b XOR c. So this is nothing but a intra-assignment delay. So what intra-assignment delay tells is the right side is evaluated immediately. So the b and c. So for example, this is b and we have this is our c signal. And if you say this is our time instance t equal to 0, and let's assume that this is t is equal to 15. Okay, so when this statement gets executed, what happens is the right side expression gets executed immediately at t is equal to 0. So whatever value of b and c is there at t is equal to 0, that will be taken for the XOR operations, and the result, which is basically generated at t is equal to 0, will get assigned to the left side variable, which is sum at t is equal to 15 time. So whatever the value of b and c is there at t is equal to 15 is not going to participate in the expression. So this is nothing but an example of intra-assignment delay. Now let's see the next statement where we have an example of delayed assignment, or it is also called inter-assignment delay, where if you see the delay value is mentioned first, then we have the sum equal to b XOR c. So this is example of delayed assignment, and what delayed assignment says is the right side expression should get executed after the delta t time mentioned, and then the value of expression is assigned to the left side variable. So here what happens is the b and c value is basically taken at time t equal to 10. So if you say, let's say that this is nothing but time t equal to 10. Okay, so when this statement gets executed, it takes the b and c value at time t equal to 10, and that value at time t equal to 10 will participate in this expression, and then whatever the result is there will get assigned to the variable immediately. So guys, I hope the difference between delayed assignment and the intra-assignment delay is clear. Now let's see the blocking assignment. So the blocking assignment, symbol for blocking assignment is nothing but equal, and the blocking assignments actually executes sequentially in the order the statements are written in the procedural block. So the execution of blocking assignment happens sequentially. For example, let's say we have a always block, and in this always block we have some three statements: a equal to b, b equal to c, c equal to d. So first this statement will execute, then this statement will execute, and then this statement will execute. This will happen sequentially. For example, first the right hand side expression will get executed, the result will be assigned to the left side variable, and then the next line statement, which is this expression, the right hand side expression will get executed and the value will be assigned to b, and then it will go to the next statement. So it will happen sequentially. And very important point is the blocking assignments are used to model the combinational blocks. If we are modeling the combinational logic using the procedural blocks, then we have to use blocking assignment inside the procedural block. And the syntax here is, this is the normal syntax, and this is syntax which comes with intra-assignment, and this is the delayed assignment or inter-assignment. So here what is the definition based on the intra-assignment delay? What is the definition? Grab inputs now and deliver the answer after the time mentioned. And in delayed assignments, grab the inputs after the delta time mentioned and execute the expression and assign the value to the left side variable. Now let's see one example. So guys, one important thing is the delayed assignments are only used for simulations. We cannot use any kind of delay assignments in our real design which is going for the synthesis. So if you see here, we have a, b and c, three variables. So this is nothing but example of delayed assignment or inter-assignment delay. So as per the definition of inter-assignment delay, wait for 5 time units and then execute A equal to B equal to C. And this is the nothing but intra-assignment delay where A will be calculated immediately. Now here if you see, this is nothing but blocking assignments. So blocking assignments execute sequentially. That means this assignment will get finished at time unit 5. So this A will be basically, what will be the A here? The A at time 5 unit. So whatever the value of A is there at time unit 5 will be taken, and after 2 units it will get assigned to D. So basically at time t equal to 7 unit, the value of A will be assigned to D. So for synthesis, the blocking assignments are like this, and we cannot use any kind of delay assignments in the code which is going for the synthesis. So this is the symbol here, equal to symbol, and the blocking assignments here. So here basically we have used the blocking assignment, so they will execute sequentially. And the blocking assignment are basically used to model the combinational logic. Now let's see the non-blocking assignments. So non-blocking assignments are represented by, or the symbol used for non-blocking assignments is nothing but this one. And the important other point is all the statements which are having the non-blocking assignment executes parallelly. So how the execution happens for the statements? The right hand side of the non-blocking assignments is evaluated starting from the completion of the last blocking assignment, or if none, the start of the procedure. So what is the meaning of this line is, suppose we have one always block and there are A equal to B. This is a non-blocking assignment, B non-blocking C, and C non-blocking D. So the execution of the right hand side of expressions for each statement, non-blocking statement here, happens concurrently. So assignment of the result of right hand side expressions will happen when this procedure or this always block gets terminated to the left side variables. And next important point here is, we should not mix blocking and non-blocking assignments in a same procedure. So basically the meaning of this line is, we should not model combinational logic and sequential logic within a same procedure. We should use different procedure for combinational logic and another for sequential logic. So whenever we have a always blocks which have a sensitivity list like positive edge clock or negative edge clock or something like this, we should use the non-blocking assignment, which will result in the flip-flop circuit. So guys, now the syntax here is, this is the normal syntax without any delay, and this is nothing but our intra-assignment delay, where we need to grab the inputs now and basically evaluate the expression, and at the end of this delta t time assign the result to the left side variable. And this is our delayed assignment or inter-assignment delay, where we have to wait for the inputs to grab by the time delay time mentions, and then you have to evaluate the expression and assign the value to the left hand side variable. So here is an example. So this is for simulation where we have two statements with non-blocking assignments. So here the important thing is, non-blocking assignments starts executing concurrently, unlike blocking statements where the first statement will execute, then second statement will execute, and so on. But here in the case of non-blocking assignments, the right hand side expression of all the statements starts executing concurrently. So friends, here is a typo. This example is type of a inter-assignment delay or a delayed assignment, where we have to grab the inputs at the time which is mentioned in the statement. So here we have to basically grab A at t equal to 3, and here we have to grab B and C at t equal to 6. Okay, if it was a blocking assignment, then the B plus C we would have picked at 9 time unit, because the 3 is from previous and the 6 is from this present statement. But this is a type of non-blocking assignment. Here all the right hand expression of a non-blocking statement starts executing concurrently. So both the statements are basically executing concurrently from time t equal to 0. So this A will be getting picked at t equal to 3, and B and C will be getting picked at t equal to 6 time. So I hope this is clear. Now for the synthesis, we cannot use delay statements. So this is the way of writing non-blocking statements for synthesis. Now let's see few concepts for begin and end Verilog HDL keywords. So begin and end block statements are used to group several statements. So if there are several statements we are using in our procedural blocks, so now to group all of them, we should use begin and end keywords. So the places where we need to use the begin and end includes functions. We should always use begin and end keyword inside functions. Where we have multiple statements, more than one statements, then it becomes more appropriate to write the code. And the always and initial blocks and all the conditional statements. And we can also optionally name the block. So this is very important here. This is another very important use of begin and end keyword. Using the begin and end keywords, we can basically name the block, and this block naming is very important during the simulation, because by making use of the block name, we can actually disable and enable that particular block. So this is another very good example or very good application of using begin and end keyword. Now let's see one example here. So this is a function. So here we are going to use some statements. So to encapsulate all the statements, we have used begin and end keyword, and the name also we have provided that the name for this begin and end keyword is nothing but adder_block. So whenever we want to disable and enable this particular function in our simulation, we can use this block name and then we can enable or disable. So guys, I hope the concept covered in this first part of behavioral modeling is clear. If you have any doubts, please write down in the comment section. And also, if you like this video, please hit the like button and do subscribe this channel and press the bell icon so that you would get notified as soon as I upload the next part of behavioral modeling. Thank you very much.